we have thrown events in Dubai and San Francisco. They're less regular, but if you're ever out there, give us a little message and we may throw another one. If you want to follow us, we're at the Docs Hub, and also it's been recorded live, so everything afterwards, you'll be able to see the slides. We'll post them on the Meetup page and also the video, but if you want to see it separately, it will be on YouTube as well. DevOps Exchange, yeah, so you can tweet us at the Docs Hub. So the Docs Hub is not just Barcelona, that includes all, I think 9 in total, but 7 of the regular meetups. So go ahead and tweet away. And if you do follow us as well, you'll get regular updates from all the other meetups and what's happening in the DevOps space. So the agenda tonight, we've got Dani, who's Glovo's own over here. He's going to be talking about how to approach infrastructure as code. And then we've got Unai, in-house build farms, and Victor. And Victor is an interesting one about evolving startup environments to production environments. So it's very broad, but all DevOps specific, but we'll be covering a large amount of topics. Oh, sorry, I'll get this to you. This is my colleague, Andy, and he'll talk about it now.
Hi, yeah, so it's a very quick word from us. We, as Linux Recruit, are a cloud, DevOps, and open source specialist recruiter. We try our level best to make this as community focused as possible, so I'll leave the recruitment out of it as quickly as possible. But if any of you guys are looking for new roles and would potentially need help with anything, find Jack or I. You can always help you out there. Just a quick word as well. We just want to say a huge thanks to Glovo. They provided this amazing space tonight and allowed us to host here. So thank you guys for that. And one last note from me really is that we need to put a save the date for the next one. As Jack mentioned, these events are going to be a lot more regular from now on. March is actually a fintech special. So we have Enrique, who will come in and speak to us, as will Mal, and our very own Mark Cluet, who's one of our organizers here. So he'll be speaking as well. Sat just over there. So yeah, that's it from us. I'm sure we can, oh, one more. If you have any need and want to speak with one of our events, just drop us a line or get in contact with Ashley over there. She helps organize our events. We can go from there. But yeah, I think that's it from me. I'll let you get on with the evening.
Okay, give me a second to get set up. Stop share. No one share now, please. Do we get it? Yeah. Okay. Where's the pointer thingy? Who has the pointer thingy? The guy. Hey, do you have the pointer? Oh no. Okay. Hi, I'm Dani. There's a slide for who I am, so I'm probably just going to skip. So hi to everyone. Thanks for coming. I really hope everyone else did like a who am I slide, because if it's only me, it's going to be very narcissistic. But I'm going to go through it, right? I'm a backend engineer. Been here for 2.5 years. I joined back when the team was really small. It was some sort of 20 engineers or less, and it's gone from this very pretty small startup to a huge thing with the whole building and like a lot of engineers. So it's been really interesting to watch the transition. Right now, there's another transition happening, which is we're migrating a very legacy and monolithic architecture to a microservices one, which is also something that probably many of you are familiar with and have dealt with to some extent. The focus of this talk is going to be mostly on how this transition happened here at Glovo, how we use tools to make this transition to improve what we were doing and improve the solutions that we were taking part in. And spoiler alert, we use Terraform, as you can probably know. We'll start doing an overview of how Glovo was 2.5 years ago. I'm not used to looking at the screen, but I should. 2.5 years ago, we'll go through what Terraform is for us, how we are using it, and how that has impacted the way we do things right now. So Glovo 2.5 years ago was a pretty small team. It was less than 20 engineers, managing less than 30 instances. We had some infrastructure as code in CloudFormation, but we didn't really do CloudFormation. We were just instantiating things by hand mostly. We did not have any tests for the infrastructure. We had not many infrastructure records per week, but we did have some. Every week, someone would come along and say, "Hey, I need to do this other project and I need some new instance or whatever. We did not have any tracking of the uptime, so like I wouldn't really be able to tell you, but I would say it was like something within the 1.9 realm. It was not really great. We didn't have much tracking of what infrastructure was out there, so we sort of just did things. We didn't know what was going on, or we didn't know how much. We knew how much it was costing because of the bill at the end of the month, but other than that, it wasn't great. We didn't have any infrastructure as code monitoring, so everything that we were monitoring was just hand created by us. We went to CloudWatch, or we went to New Relic, and we added the monitor, right? The infra team was one engineer who's not working here anymore, but he's a great guy. His name is Roberto. If he ever sees this, or if anyone knows Roberto, he's currently working on New Relic. Common problems for us were very, I've tried to categorize them into what problems as an organization we had. The first one is permission requests, right? Can you give my new developer access to this machine or this new project? Maintenance, whatever thing broke down because it was not well maintained, so I need someone to come in. Course monitoring means that we had a big overview of the things that were going on, and if something broke down, we got a monitor, but it was very generic, like the service is down. But we didn't have a fine-grained look at what was going on. We had lots of info requests, well, not lots, like maybe once or twice a month, as I said before. And every single time that this happened, someone had to go and manually create it for them, so it was a blocker for everyone every time this happened. We had deployment issues, which is basically when something breaks in production, what do we do? Usually the infrastructure was not known by the teams or not controlled by the teams, so they would just rely on us to do everything. Well, not everything, but most infra-related stuff, which goes against the sort of principle that everyone should own their stuff from end to end, right? Accountability. Meaning we wanted to know who was consuming what and what was costing us the most, and we didn't really know this because nothing was tagged. No one knew whose instance was what or who created what. So the solutions for this were, sure, here you go. Sure, let me do this. We don't really have any monitoring. Sure, let me spin this up for you. Sure, let me fix that for you. We don't really have any accountability, right? It works, but it's not great if you want to scale up to 200 engineers. So before saying that we picked Terraform to fix some of these issues, including others, I want to actually introduce Terraform. I know that some of you already know what it's like working with Terraform, or have at least read about it or have an idea of how it works. So I'm going to sort of floss over this section because I'm not really controlling time, but I'm probably not good. And if there's any questions afterwards, just let me know. So Terraform is a way of defining, instantiating, and managing infrastructure. It lets you write infrastructure as code, meaning that every single thing you want to create in any of the providers that you currently are using, you can write a file for it in a predefined language, which is ACL, is their own language. You can plan, like you can ask Terraform, hey, is this file that I've written okay for going into production? What is it going to actually do in my provider? So it will plan the changes for you and show you before applying them. It is multi-provider, so it does not only work with AWS like CloudFormation, and it works with an array of different providers, and it also allows you to do not only infrastructure management, but also configuration management. Like if you want to configure monitoring, or if you want to configure schedules or whatever, you can also do that with Terraform. There's actually over 200 providers. It also does a stage management, which is basically once you instantiate your infrastructure, it will keep track of that. It will understand the changes that happened outside of Terraform to it, and it will correct them every time it has a chance. So if anyone touches your infrastructure after you've declared uninstantiated it, it will correct it for you. So it also sort of acts as a watchdog in case you accidentally or someone maliciously changes your stuff. Why would decided on Terraform instead of other tools like CloudFormation or Troposphere or any other CloudFormation-based tools? It was because of a few things, and I think that they're worth it. We had a big discussion on why we're doing this, so I think it's worth to share the knowledge. We did this once, and I think that one of the major features was Sentinel policies. Sentinel policies are a thing that works with Terraform and lets you apply code-based policies every single time you instantiate something in production. So you have any array of policies that you want to enforce, you write them as code, and they will run every single time someone wants to do something with Terraform. Syntax, it's, at least for us, it's way easier to write Terraform as it is to write other tools. It still is a declarative language, so it does not allow you all of the possibilities of, say, writing infrastructure in Python or in any other programming language like some tools do. We think this is a good thing because it allows us to be more opinionated about the things we do. Tooling, it includes Terraform Cloud, which is a state management. You don't have to take care of additional infrastructure. It's a software as a service. Integrates with the GitHub wall. All of your PRs are checked. All of that works out of the box. You don't really have to do anything. Many providers have said you can use more than one provider, not only AWS, you can also use Datadog or other stuff. It has a very, very active community. It has some of the fastest support for most of the things that come out. Things are supported in Terraform before they are supported in CloudFormation because Terraform, they work with the external API and CloudFormation needs to support things internally. So you actually, even though it's not from within AWS, AWS has better support in Terraform. Easy adoption, we think that it's just really well documented. We are not detractors of the AWS docs, but the Terraform ones are pretty good. So we're gonna go through really quick through a hello world for Terraform. How does it look? Like all of this stuff I'm talking about. Does it actually work? Well, you tell it, hey, I want to do this in AWS. This is an AWS project. You declare a data source, which is, hey, I'm referring to something that I'm not actually creating, that is already created for me, but this is the reference to that. So for example, here I'm referring to an AMI in AWS, which is created by Canonical, and it has a specific name. And then I'm saying, okay, create this resource for me. I'm gonna have an instance that I call web, and I wanna put a tag that is hello world. This is very simple. It just creates an instance in AWS, right? But this has, like, the language itself has many more nice features which allow you to create many more complex projects. Like, for example, for each construct, this allows you to create one machine per input. So for example, if you have this list here, you can create a machine for each part of the list. It also has other dynamic blocks that let you do many things in a sort of iterative way, which is very good if you were trying to do scaling things or trying to do things in many subnets and many availability zones, that kind of stuff. The one feature that is most important to us right now is being able to write modules that are reusable by everyone else in your organization. So you can declare sort of a sub-project of Terraform that others will reuse to create their own stuff. This means that you can opinionatedly create one file that enforces all of the stuff you want to do, open up that file to everyone else, and they will have to sort of go through your way of doing things. So if you want to, as an infrastructure team, if you want to enforce a certain way of doing things, this is the best way for us. How it works is just declare some variables for your module, declare the resources within your module, which can be many, specify some outputs, and then just let people use the module, right? An extra thing from Terraform Cloud, as I mentioned before, one of the biggest features is Sentinel policies. Sentinel policies allow you to do things as code, and this is an example. So if you want to validate the cost, this is something that Andre wrote. I don't know if he's here, but one of the guys here wrote. This will actually validate the cost that your plan is incurring in the platform. Every plan comes with a monthly cost expectation of the resources that are being created. And if it goes over a certain cost, it will just mark the plan as invalid, and it will request a review by someone. Every single Sentinel run can mark a plan as to be reviewed, a recommendation, or green. This is sort of how it looks in the Terraform Cloud platform. It will run all of our compliance mechanisms, and it will tell you which ones are failing and which ones are passing. If we deem it necessary, we'll sort of make the plan need a review from someone from a platform, just to make sure that you're doing things the way we want you, right? So how do we use this here? You can still use all of the usage, all of the tooling that Terraform Cloud provides. But we use Terraform Cloud as the one provider to store a state, to sync everything, to host the states for us. So you have to go through that every time you do a pull request, every time you merge something, that's what it's going to apply. So it looks something like this. You write the code, you commit it to GitHub, Terraform Cloud actually picks it up. We'll review that for you. We'll do the Sentinel run. Someone will review if necessary, and then Terraform Cloud on its own will apply the changes. So it's not anyone from platform. No one from platform is actually involved. If you're just passing all of the checks, you can just merge it and you get your stuff in production. You don't need access to AWS. You don't need anything. You just need access to GitHub. Okay, so that is an overview of what Terraform is or what we use from Terraform. Has this impacted Glovo? So Glovo now is a very different organization. It's a organization with 150 aiming for 300 engineers this year. So it's pretty ambitious. We have more than 300 instances in production. I think it's way more, but I wanted to be conservative. We scale up and down a lot during the day. So we are mostly on Terraform. Still have like 100 or so stacks in CloudFormation, but we're slowly transitioning. We have more than 0 infrastructure tests. I wouldn't be confident in saying how many we have, but I think it's more than 0. I'm sure it's more than 0 because I've read infrastructure tests today, and I actually did some. So that's good. Infra stages, we have several infrastructure changes a week. So we have several Terraform plans running a week and doing actual changes in production, with many of them without explicit review from someone from platform. We have an uptime of 99.5 to 99.9, depending on the week. Sometimes we do better, sometimes we do worse. We're aiming for 4 nines eventually, even though the internet is 4 nines. So yeah, that's better. We have most of our infrastructure and infrastructure monitors as infra. So more than 60% of the machines that are currently instantiated are done through Terraform. More than 70% of the monitoring that we do is through Terraform. So we put out Terraform modules that specify monitors. People use them and they create dashboards and monitors for them. The infra team is now 7 engineers and 3 engineers for build, test, and deploy. I don't know why I included this stat. I guess it's not super efficient because before we were doing all that stuff with 1 guy and now 10 guys. Well, anyway. So let's revisit with the problems we had before and see how they are solved now. Before they were very like, let me do this, let me do that, let me fix this, let me fix that, right? Now, if you have a permission request, well, you open a PR, right? You go to the relevant Terraform repo and you open a PR. Because every single person is accessing AWS through a role, and that role is kept track of in Terraform Cloud. If you have maintenance fire, like this machine, I need to increase this machine because otherwise it's going to blow up, you can just open a PR and have it increased without us having to come in unless it's a super big machine. Course monitoring, you don't have to create stuff manually. You can just clone our own declared Terraform module that is very opinionated and will sort of standardize the way you do tracking for your service. And you can create that. You don't need to know about Terraform that much. You just input your resources and it creates a dashboard for you. You get an infra request. We just point people to their Terraform Cloud, Terraform repository. Give them an AWS account if needed, because we have a split of AWS accounts now. And we tell them to open a PR and we will review it if they want to. We have a deployment issue. Well, we just point to the TF repo and we say, hey, you can open a PR if there's a problem with this. Realistically, we sometimes, like lots of the time, we help because it's important to help out. But we do have everything in Terraform Cloud. So in the end, we're just like helping them out, check out what is wrong and fix it in Terraform. And for accountability, we have a very nice Sentinel policy that checks that everything is tagged properly. So whenever we want to know who's spending what or who's doing what in Terraform, in AWS, we just check the tags are made sure to be there by our Sentinel policies, and we know who is spending what. This is also all a bit idealistic. So the truth is we're doing all of these things. Sometimes the coverage is not 100% yet, but you get the idea. There are extra problems that we also fix with this. There are problems that we didn't have 2.5 years ago, right? So security concerns, like we want to limit who can change IAM permissions, because if everyone can change IAM permissions, everyone can do anything, right? The solution is just build a Sentinel policy that notifies you every time someone's trying to do something with IAM, and you can prevent them from doing it, or you can enforce a manual review. Preventive cost management, so preventing people from spending money blindly without going through someone first. So if it's exactly the policy I showed before, if the cost is going to be too high, it just requires a review. Infra standards, so we have many sort of documentation-based things that tell you, oh, you should do instances like this, like that, you should do groups like this, like that. But the most useful way is just to provide a module that does everything for you, and you don't really have to worry about Terraform. You don't need to know that much about infrastructure. You just declare your module, creates the stuff for you, and you can use it. More other standards are not that much infrastructure-based, like tagging or coming up with naming. Sometimes we have like an enforced policy for naming. I don't think we have a Sentinel policy for that yet, but we're writing it. Other stuff like we need a disaster recovery plan. Of course, if you don't have infrastructure as code, you cannot do disaster recovery that well. So right now the plan will be start reinstantiating the stuff you have in your Terraform files, and then try to bring back your backups. Also service config management. So we have, for example, Datadog. We have over 700 monitors in Datadog. They all need to be managed. So we do that with Terraform now. Learning. So I think this is the most important slide, because this is sort of what happened while we were doing this, what we learned from the whole process. The first thing is standardizing is important, but it's important to standardize with tools. So if you want to enforce something, docs are nice, but not everyone reads docs. There's people joining the team every week, and it's important to enforce these things through code if you can. Terraform is a really good tool for this with Sentinel policies, but it's really hard to maintain things when you have a 150 team of engineers and you cannot go behind everyone, like go after everyone and say, hey, you shouldn't be doing this like this, right? Knowledge sharing is really important. So if you're introducing any tool at all, if you're introducing observability or Terraform or whatever, make that a part of, like make workshops and knowledge sharing a part of the integral process. Make sure you add this in the onboarding. Make sure you add this everywhere so everyone is aligned with you. Otherwise, people start doing things outside. We had people writing CloudFormation before migrating to Terraform, and it was a mess. Try to, this is more of like a sentiment thing, but try to not be sort of going after everyone. When you're a sysadmin or a system engineer, you want people to do the things your way, or you want people to do things in a good way. But it can feel as if you're being the police of everyone else if you're just going after them and saying, hey, this is wrong. Try to give them the tools so that they can do things right without having to think about it, instead of trying to just make them comply. The good feeling for everyone is to feel like they're not blocked by infra, right? To feel like they can just PR anything and anything will get deployed. Obviously, this is not going to be the case, because if you PR something that doesn't make fucking sense, we're not going to merge it. But they should be able to propose anything, and us just have to be reviewers of the thing. Automate. Well, this goes with what is on top, but yeah, automate everything. If you can, always prioritize through what is the most important for you as in security concerns go, and also what is the thing that is taking the most time away from you. So if you're most often running after people for tagging or whatever, just build a policy for that. Let teams take ownership of their infrastructure means that they, like, this is a very common thing we say in DevOps. Everyone should own their infrastructure from start to finish. If teams don't need to actually have all the full knowledge to do everything themselves. They should have the tooling in place so that they can do this themselves without actually knowing deep down to the lowest level. So you should strive to make tooling that will actually work for everyone, not only for system engineers. Being opinionated on infra is not bad. This is something that people will disagree on, some people, but I think this is a good thing. If you want to have a homogeneous and a understandable sort of approach to infra, you need to declare what you want to build. So you need to say, okay, this is the way I want to do whatever piece of the infra you're doing. It's not bad to settle on one way of designing things and doing this. Okay, I'm like 2 minutes away. Have a clear boundary of the dynamic deployments and the infrastructure. So one thing we went into first is declaring all of the dynamic infrastructure, like the dynamic blue-green deployments with Terraform and all that. It was not the greatest of ideas because there would be lots of deployments of Terraform for this project a day. So in the end, we used Spinnaker to deploy everything that was dynamic, and we just declared the static infrastructure with Terraform. We find this to be best. Abstract for example, so don't try to build something like abstract a module if there's no one using it. Try to abstract something that people are already doing. This is very basic, but it was really hard. And a quote by John Martinez, which is over there. Always try to know which problems you're trying to solve, because if you don't, you're just really adopting things because it's fashionable, because other people are doing it. I think in this industry where everything is changing a lot, there's many technologies that are considered to be good. And I think the one thing that we did well is always try to find out which problem we were trying to solve before we adopted something. Yeah, I think that's it, right? Okay, thank you all for coming, and this was my talk. If any of you have any questions. Should we do questions or?
Yeah, does anyone have any questions?
Hello. Yeah, it's a nice presentation. My name is Asim. I think I missed the part. You guys are using blue and green deployment through Terraform, or it's a canary-based or?
We are doing deployments with Spinnaker right now, which is a Netflix sort of technology. We declare the static infrastructure with Terraform, and then Spinnaker handles all of the changes to the groups, the target groups, the versions, all of that stuff is managed by Spinnaker.
I think Danny's going to be sticking around for a drink afterwards. So if anyone's got any other questions, I'm sure we can catch on up on that then.
Am I really late or what?
No, you're not too bad. Just keep on time. I think we've got our next speaker. He's going to come set up and grab another beer if you want while we wait, but it shouldn't be too long.
I think I'm sure late.
There you go. Yeah, check your work.
Yeah. Work it to do like 20-minute talks. We'll do like we're waiting to get. I only have a few slides here. Right. Just give it 2 minutes. Let people grabbing a beer. You know what I mean.
Yeah, I'll tell you what. No, just give my colleague the microphone here because he's going to fucking tell people to come on. You know what I mean?
Sorry. What's your name again? Unai. Sorry. Hi. So I think we're ready to get going again. Has everyone managed to grab a beer and comfortable seat? So Unai is going to come and, no, nearly, I think I've got everyone. Sweet. So Unai is going to give us a talk on in-house build farms. Hand you over now.
Hello. All right. Working. Good. Good. All right. So I don't quite have a slide about myself, but very shortly, I am the, you could say the CTO of a startup nobody knows about, and probably nobody know about because we're actually selling out this month, which is good news, by the way. This story is about my previous life when I was a DevOps engineer at a really large company here in Barcelona. We're talking 2014, so things have changed quite a bit. I don't even think DevOps was a word back then in 2014. Roughly, back then we had VMwares. Nowadays you got Docker, you got Amazon Web Services, you got Kubernetes, you have all these beautiful things. Back then you had Jenkins, which was quite disgusting. And nowadays you have Circle CI, you have Travis, you have all these beautiful things that help you out as well. Back then we had this guy, and yeah, not everything is progress. So to put it into context, we have many, many products, right? We're talking printers here. And all of them, they share the same code base. So you had all these same repeatable modules like the UIs or the network code that had to be coexist in the same trunk. We had around 20 different builds for every branch, right? Around 300 developers just on site. I'm talking pure core developers committing actively to the single branch. And the compilation time was around 30 minutes. Actually, it was 2 hours, but we managed to tone it down to 30 minutes because the coffee breaks were taking a bit too long. And no feature branches. It was completely forbidden because it was the way it was, you know. So basically, you can imagine that every time somebody committed something that broke the branches, that would happen. Everybody would be chasing this guy down to his place, trying to make sure they fix it. And that was actually me on my first day of work. So on the bright side, we actually did have a few things going on for us. We had many, many idle workstations sitting around the office for no particular reason, just that people like to stockpile workstations next to their places. We had one official server room with all the beautiful racks, you know, like Google-like stuff. And we have an unofficial one with some shelves that were actually combing under the pressure of the actual computers, and it was a disaster waiting to happen. We had some undemanding compilations, so not everything was 30 minutes. Some things were like chipsets for particular, you know, like microprocessors that would take like 5, 6, 8 minutes to compile. And we had a single setup process, which you will see how this is relevant, because every single machine that was going through the company was running the same process, which allowed us to have one single common user for all the machines set up for us. It also allowed us to have DNS records pointing to the aliases of these machines. So basically, you could find a machine called 001 that would always be 001, and you could SSH into that as long as you were in the building, which was every single machine. Right, so this is what we thought about. We clearly needed a bit more CI. And we needed to build a system, so we thought, we have all these idle machines sitting around, why don't we script something that will allow us to use this computing capability to compile all the products faster. And the system had a master, which was on the good server, and they had many slaves, which were basically all the little machines that were sitting around the office. Now, the master was responsible for orchestrating the builds, gathering the reports, and actually being the main point of configuration. So you could specify everything in the master that you wanted to be compiled on every cycle, or as soon as it was available. And then all these slaves, we only just have to build it, right? The slaves also keep the results and the logs, and they had to stay updated. And that's quite relevant because we had the same tooling folder installed in every single machine. and we could just update it with a regular, it wasn't even Git, it was Subversion. Right, so roughly the process looks like this. You get a master that on a cron tab pulls your branch, all your branches, I might say. Then, if it defines no changes, you just exit and just wait for the next pull, right? If you do have changes, what it did is it created and dispatched tickets to slaves, right? So you create a single file with information of the compilation that were meant to be running, and then you would straight up SSH copy it to a slave. Now, the slaves, they have another cron tab, and the cron tab is just responsible for, I'm gonna read in all the tickets I have, and whenever I find a new compilation, okay, I'm gonna be locked, and I'm gonna be compiling this. So don't bother me again for a bit. Now, eventually, the master also has to pull all the slaves and find out what they're doing, because the slaves do not report to the master directly. And there is a good reason for that, because you don't know what's going to happen with these machines. I mean, somebody might just come and just switch the plug off and break this actual compilation. And if that happens, then we just find another one for the next cycle. We don't want to be enforcing these machines to, you know, be up and alive, because we cannot guarantee that at any point. So that's pretty much how it will look. This is, so just for your information, all these scripts were Python and Bash. So that was quite a craftsman's work over there. This is the folder structure of what a slave would be, which is like straight up file system, sort of file copying stuff. So you will have the etc CM, which was the continuous integration manager names. And then you have the tickets and you have the logs, right? And within the tickets, you could find the different stages a ticket could be in, you know? It could be pending, it could be working, it could be done. I think there was more, I just can't remember at this point. But the ticket is always the same thing. So it doesn't quite change, it doesn't quite update status. So the ticket would be defining the branch. It would be defining the actual sandbox name, which is automatically generated by the slave. So if the slave is trying to compile something called branch A, then the sandbox would be sandboxes branch A. And then you have the revision that is trying to compile. So it's very simple. The slave just takes the ticket, you know, updates, refreshes to this particular revision, fixed. It's never the latest. It's always like the one that we give it to you. And then it starts compiling it. When it's done with it, it moves from the working folder to the done folder, and all the logs will still be visible in the logs folder. So this little code was actually just about 400 lines for all the master and slave thing, right? But it actually saved our lives back in then. I'm moving forward. I have more, I swear. No. Jesus. Okay, this is it. The configuration, pretty much, there's one single entry point of configuration, and that's in the master, right? And you define everything in a very, very simple way. So you define the pool of machines that you have available, and you just find the alias, but in all the other case, it could be the IP address as well. And you say, what's the capacity of the machine, right? So we assume that 1 is the full capacity of the highest machine that we have in our sort of, you know, infrastructure, right? And then we assume that if you're gonna package the highest needs, you know, for a compilation, that's gonna be requiring a machine to operate by its own, right? So you can do some sort of very simple, quick mapping between what does a compilation take and how many compilations can be of the same type can be running at the same time in the same machine, right? So the next thing we need is the branches that we are going to be testing continuously. So the branches are just defined as an array, and you can find the URL of the branch. Everything is relative to the trunk branch. There is no different repos at this stage. And you can find the different targets. The targets are basically the different processors the code is being compiled for, right? And this is like a compilation target by itself. So build type, options, target, blah, blah, blah. You just define it over here. Now in hindsight, that was very quick and dirty, but it actually helped us quite a bit. So we managed to almost make sure that every single commit was being tested using about 100, 120 machines workstations we managed to scrap from the entire office. Now, in hindsight, you could even improve this thing, and this is just like a theoretical exercise we did, but no one actually had the time to implement it. We could potentially read the specs of every slave and find out how powerful are you really, yeah? We could even get smart and find the usage of the slave in this particular moment in time, so you would not dispatch a ticket to a slave that was actually being used already, right? So you prevent these situations where one of the compilations is running slower than the rest. And finally, you could even get smarter and do like crazy things like, let's find out where people are not in the office and try to build as many nightly bills as possible, because we can know and record the statistics of when computers have been used by whom. Even funnier, we can even find out who's got recurrent meetings and know he's not compiling his code on the Monday mornings, and we can actually use his computer for this. So that's it for me. Not much, but hope you enjoyed it.
Great, thanks for that. Does anybody have any questions or?
I'm also from the Stone Age. I can understand your pain. So at that time, there was a tool for the monitoring as well, MRTG and PRTG. Do you remember that? Oh, okay, that's fine.
Do we have any other questions or? Well, as you may have noticed, pizza has arrived, so we're going to have a quick break, let you guys grab some food, something to drink, and then we can go from there and we'll convene for the third talk. Cheers.
That was it. Just pizzas here. There's meat, vegetarian.
Can you, do you need to wait 5 minutes or? Sweet. Thank you. Yeah, very good. So what's interesting? He was a super range. It's good talk. I'm the least technical. Let me go see if I can find one of the guys from.
En plan de, ya estoy en programa.
Hiya, so has everyone managed to enjoy some pizza? Let's get themselves another beer. I know we had to run out and get a few more. Brilliant, brilliant. I think we're all back seated now. Thanks for joining us after the break. We have Victor, who will be giving us a talk on taking startups through to production. So,
hello, thank you. I was going to do the joke that I was between the beers and the pizza, but it went wrong. So let's do it. So I did as well who I am slide. So Dan is not going to be alone. Yeah. Then I have been working as system engineer for more than 10 years. I have previous experience like doing evolving infrastructure from the beginning. Actually, I'm working as engineering manager in Holded. As you can see, I am owned by a cat. He's my real owner, my boss. And you can find here my LinkedIn and Twitter. So I am more used to do more technical talks, but today I want to share my experience coming to Hold It and try to make it better. It's not going to be super technical, so sorry about that. It's more my thoughts, my experience, my problems, and so on. And I wanted to do like a journey. So when you come to a place, you are super happy, you have a new job, and you are going to do amazing things, and you went to your first day and at work, and you find it a super jungle, and it's super messy, and needs to do a lot of things. So first things, you need to, my idea is, okay, I'm gonna to know what is going on, what is good, what is bad, and so I need to get the maximum information from the current status. Then I write down a list of potential problems, issues, or that detected, and talk with every tech person in the company, so you see in the real thing that it's going on. So I have did some live examples here. Like, for example, I was learning about the current infrastructure and writing down in a diagram that I realized that servers wasn't in high availability, backups weren't testing, release to production takes forever, there is no monitoring, no homogeneity in servers. It was like, wow. So I decided, okay, let's calm down, and like doing a trip and you want to go to Japan or something place, you start exploring options like, okay, my idea is don't get overwhelmed. You have a lot of things to do. You are short of resources. You are alone, so you don't get overwhelmed. So I did a list and identified the most urgent matters to resolve and draw different solutions. They don't need to be the final ones. For example, servers was in AI, decided to, okay, I can clone the server and put a load balancer there, or maybe I can put a Kubernetes and say, hey, this is a microservice, it has the all sense in the wall, and hey, let's use Kubernetes. Then the backups, okay, test backups, nothing else you can do here. Release to production takes forever, review the flow. In this case, we were missing some automations like CI/CD. We are going to use Jenkins, we are going to use Circus AI, what are you going to do? There is no monitoring, okay. What I can do here, maybe I can hire someone that do the monitoring, like Datadog, New Relic, or someone, or I can make myself, that will consume a lot of time. And at least the no homogeneity in the servers, for me, the solution was clear, like using some infrastructure that code, like Ansible, Puppet, or Terraform. So we keep planning our trip here. Like real trip, we need to decide where to go. So at the end of the day, it's like a personal taste, like cost-efficient time that you do the thing. So for me, it depends. You can talk with someone and may take another approach, but for me, it was this approach. So I decided to create an infrastructure with Kubernetes because it has a lot of sense to me. Test backups. At the end, I got experience with Jenkins, so it was easy for me to create a Jenkins instance. Then we hiring Datadog because it was super fast and easy to have monitoring with Datadog and PagerDuty. And then the server for me was Puppet, with something new that it built. If you didn't test it, it's awesome. It's the mix of Ansible and Puppet. It's super cool. And then also I did Terraform modules for creating Kubernetes and servers. Oops. So you start working like, hey, I'm gonna do things a lot faster. I have a lot of it to do. But you are in a startup, the things never go as you plan. You are in an environment that is growing a lot. It's normal that new requirements appears. Team is growing, people are evolving, people have new necessities. So you need to rethink your strategy with the requirements like we did at the beginning. Don't get it like, wow, I'm gonna die. Just keep it calm and do it better. For example, what happened to me, it was like we needed to creation of the squads so we can divide the team and the things that they do. We're introducing Agile in the company because we didn't have any Agile, like dailies, retrospective, and so on. Then the Git flow wasn't really defined, so the releases to production was delayed. So we introduced the Git flow, and then, you know, it's time to do that. QA was super demanding that they wanted to test new features, brands, and so on. So we need to create this and a super large list of things that you were asked. So, and then you finish it. You finish your list, and then you say, I am done. At least I can go to vacations. Are you sure you can go to vacations? There is always some things that you need to do. There is a lot of challenge. There is a process to improve or create, start planning, talk with tech team. Always saying that you need to talk with your tech team because it's super important to have feedback of them. At the end, they are working in your code and they know better what they need. And yeah, you see that list, it will keep growing every time. So don't get afraid of that. What I wanted to say with that is like, that was my journey. We have a lot of things to do, but now we feel confident. We are releasing to production super fast and so keep calm and don't get overwhelmed of that. No, I don't know if you guys were in a startup environment, but it's super messy, but just keep calm. So it's super short because, yeah, it's almost the hour. So if you have any questions and answers, you can say it now.
Anybody got any questions they'd like to ask?
What is your current development flow and how often do you deploy to production now?
Right now, if I don't get wrong, I think we are releasing like once or two a week. For hotfix, it's released like in hours. So we are improving this. We want to do it like release super faster, but it's a slow process because there is a lot of legacy code and people that they only have the expertise to do that pull requests and approve it. But yeah, it's 1 or 2 times a week, more or less.
Come on, I could see a few more hands up last time. Any other questions?
So I have 2 questions. one is how long it took you, and the second one is if you were able to, I don't know, find the resources inside a company or hire the people that you needed to pull this off.
Okay, regarding the first question, it took me like 6 months, but because almost I was living there, so I was missing a bed there. And then I got promoted to engineering manager, so I have more decision of the people that we are hiring. So we are hiring more senior people and we are doing things better. But yeah, my idea was talking with my boss and say, hey, we need this kind of profile, we need that, and we need something else. And when it was getting better, also the people get in the company. So, but in overall was six months or something like that.
Do we have any other questions or? Yeah.
So a little thanks and a little bit spam. We're hiring. If someone wants to join to hold it, come to say hello to me. Thank you very much.
So thank you very much, everybody. This was the DevOps Exchange, February, as I've said, February 19th, we have another one. We hope to see you all there, and hopefully we can help Victor out with the hiring as well. Yeah. Thank you very much, guys. Cheers.